Or yeah, you can tell. I don't know how to do that. But, yeah.
Resume recording. I think I just paused. Oh well, I didn't record those, but you guys saw it. So these are the in-class exercises we're doing. The first one looks like a scalar problem, and you could do it using scalar moment calculations, but since we're doing 3D moments, then you want to do that using Cartesian vectors, doing the cross product. Oops, speaker has changed to speakers. All right, continue recording. Great. So again, for all these, you're going to find, at least the first couple, you're going to find R cross F. And in the first problem, you can choose, two different position vectors. Likewise for the second one. And the last two are doing movements about an axis. Anyway. You're all doing your own problems?
Yeah, I guess.
Don't you want to have that dialogue thing? You guys know what you're doing? You all feel pretty, did you all watch the video? So you feel pretty comfortable about this? Pretty straightforward?
That was the first one.
Good, okay.
Here. You want to do this one? 411. Good. Looks familiar. It was in the. Yeah. Yeah, I know.
So Isaac's doing 10, he's doing 11, and you're doing 13. See, if you didn't watch the video, you might not know how to do this one, 13.
The second video?
Yeah, 13 is for the second video.
Oh, okay. Well.
So, what do you got? Are you working? What are you doing, Matthew?
Well, I was gonna do 14, but
you could if you want to. Did you watch the second video?
Yeah.
Okay. And you could show them how you did it. Or David, you want to work with him on that?
Yeah.
Or do 13?
Yeah.
Good.
No, I was thinking that when it's like along the x-axis.
Draw a picture first.
You don't have
Good.
to do a bunch of
Okay.
fancy stuff
Thinking
like
it through.
product or anything.
But the
Yeah, you can
this,
do it.
this
So how are we going to do this?
the course. Because I was watching like the first video, and the reason they did it along the x-axis is because the course went by, or was
Well, eventually
contact with that.
it'll make contact with it all the way down here because it's going.
But I mean, like directly in contact. It's like the portion of the type.
No, yeah, I know what you're saying.
You want some hints?
But I don't know.
How to,
Okay.
I forgot how they did it. I like just watch this.
So you're trying to do the moment of that force F about the point O, right? And the moment form you're doing in vector form, moment in scalar is just F times D.
Mm-hmm.
And, you could figure out, you could do this in 2 dimensions pretty well if you found out what the X component and the Y component was. The X component wouldn't have any moment about O. The Y component, times this, times 4 is going to be the answer, which is great, but let's try practicing using vectors, right?
Mm-hmm.
So to do vectors, you're going to have to find F in Cartesian form.
So relative to X, Y, and Z.
You got to find the X and Y components of F and write that as a Cartesian vector.
Z is no Z.
Yeah, but you can put 0 times K if you want to.
Yes.
And then you need a position vector that goes from the point to the line of action of the force, right? So you could either do your position vector could be OB, ROB, or ROA. And you could actually prove that to yourself that it gives you the same answer. So I actually recommend on this problem that you do it both ways. And you'll see you should get the same answer. Because the definition of the moment is that, marker, is that any, you can use, so M, O is going to equal R cross F. And the question is, what R? And R is any R
I think we can just like ignore one of the
that connects
components of that. Sweet.
O
Thing.
to the line of action
So
of F.
Yeah, because the vector continues. So this is
Yeah, and they purposely drew it that way to show you that you have two choices here.
Okay.
And sometimes it's easier to do one position vector than the other, but these are both fairly easy, but it's good practice to try them out and to see how they work. So here's ROB, and here's ROA.
Right, but I think you can just do it where.
So this is ROB, this is R.
Since it's aligned with
ROA.
the axis, I think we can
And so you have to define F as a Cartesian, ROB, and ROA, and so it's going to equal ROA
This is the Y.
cross F, and it had better equal
You have this distance,
ROB cross F.
which is 0.5. Okay.
Kind of going into their territory there, but
F, which is what?
okay, so you've got to define the Cartesian vector F,
Since
and then
it's only on the
define
x-axis, I'm pretty sure.
ROA, define ROB, and then do the cross product.
So you want me to do both
So then
ways?
what's that?
I do.
What's that equal?
Are we going to be doing like the 14?
70, how is it going over here? You've drawn the picture,
Yes,
good.
yes,
You found ROB,
Reason, like, when it's longer with the x,
and
that simplifies to the y.
I don't think you need UOB, because you're just going to do R cross
But
F,
what's this angle though? If this
Oh,
is
but-
3
right?
What will my values be for R? For R.
Pardon me?
What will my values be for R then?
Wait,
Well,
so
your values for R will be this,
Oh, so
I plus 4J plus 2K.
okay, yeah.
so you don't need to find
Yeah,
the
it's
unit
3
vector
plus
of
5, so
that?
this is-
Well, when you do a cross product, you don't really need to. The cross product is going to be R cross
so,
F.
Okay.
So you don't necessarily need U.
then we know what F is. 'cause it's
And-
broken down into IJK.
X is
So-
1, Y is 4,
Mm.
and Z is 2. Yeah, so that's ROB. So the other thing you got to do is what?
And we have this
What's the next step?
Find force.
Sorry, find F?
Yeah.
Find F as a Cartesian vector, right?
So now this is just like a 2D moment thing.
Wait,
Like from
Will
last
that
week,
be
remember? And I think the reason why we can ignore the 150 is because, or no, we can't ignore that. We can ignore this. Because we want to find out what it is in the X. So actually, no, never mind.
Finding F as a Cartesian vector, how are you going to do that?
oh dot? No, yeah.
Yeah,
No, no need for a
that's
dot.
what we should do. But the height is on the XY plane, so I don't know.
So
Sure you don't want to just do like. just
do you know
cross these two?
Yeah,
the magnitude of
we should
F?
Just do that. There was some easier way to do it. I just don't remember. So let's
Find
do
it.
that.
Wait.
So
The magnitude of the force? Can you find it?
ROA.
Can you look at the diagram? Is it?
Yeah, ROB.
Yeah, sorry, ROB.
What is the magnitude of F?
So we can say that's
120.
Okay, good. What's the direction of F?
oh, does it tell us how far it goes down? Oh.
Negative. It's going.
Negative. This is 3 dimensions now. What does negative mean in 3 dimensions?
Clockwise.
So then we need to get
Force. We're talking about a force. What's the direction of the force?
It's going down.
Going down. When I look at this, so point to the force for me on this diagram. There. Is that force going down to you? Is that accurate enough?
No.
I mean, when you say going down, I think that means this way. Doesn't down mean that way?
Yeah.
So what's the direction of the force?
To the left.
To the left. Okay, well, sort of. To the left and down, right?
Yeah.
But more specifically, what is it? Where is that thing going in 3 dimensions?
Towards the x-axis.
Towards the
positive.
x-axis. More specifically, what is it oriented along? You can find that. You can find that. If you wanted to find, like, if you needed to find a unit vector in the direction of f, what would you do? A unit vector has 3 components, right?
Yeah.
How would you find the unit vector that's going in the direction of f?
Oh yeah, so yeah, you're right. So then you cross. So what you could do is just cross those, yeah.
I really don't know. I'm blanked out for a second.
Okay.
So,
Well, you see that line that's connecting from B to C, and the force F, which is kind of going along that line.
yeah.
Can you make a unit vector that goes in the direction from B to C?
Yeah, just take the points from B, C. Then you get a R of B to C.
RBC.
Then you do the unit vector to get B to C.
Yeah, and that becomes a unit vector that's oriented in the direction that F is pointing.
Oh, okay.
Right.
And that will be your F.
And then you multiply that by 120, and that will be your F.
Okay. Okay.
Yeah. Okay, so try that. And Isaac, how's it going? You got a value for F, and you just kind of did it by inspection, right? You didn't have to do any position vectors.
I had a question though.
Yeah.
It looks like F is in the negative Y. Is that correct?
F is going in the negative Y. Yes, that is correct.
Okay.
So it's 400I minus 300J.
Okay, so I did that right.
Yeah.
Okay, cool. I was like,
And ROA is 030. And ROB is 43. What? Look at that again. ROB.
B.
100
B
plus
is
minus
X.
ROB is going from here
Or
Wait, which one?
to here.
oh yeah, that's wrong.
Oh yeah, so it'd be point. Yeah. Yeah. So
No.
That's wrong. 0.
That's better.
Yeah, it's true.
So you do an ROA cross F, IJK 030, 400
that's the
minus
same.
300, 0. Coming over to you guys. You guys are doing the moment about an axis, right? So what are you guys coming up with so far?
So they give it the F.
They gave you already F in Cartesian form?
Yeah, they give it to us. So we just decided that we'll use the triple product. But I
Okay.
think there's another easier way to do it. I just don't remember.
There's a scalar way, but
Yeah, the scalar way. But
see how that looks. So you got the F. We can go over the scalar way in a moment.
okay.
And
we determined that we want to use
what R are you going to use?
we did ROB.
OB. Yeah,
Yeah.
that seems like your only choice, I think.
So then I just wrote this down generally. So then we'll take the unit vector of the X, which is just I, and we'll dot that with whatever this determinant comes out to be.
Yep. Good.
Which will just give us the 20. So
Yeah.
But the scalar way, I was trying to figure that out, but
Yeah, I'll go over that
Since-
once you get it.
yeah,
First
okay.
one. Oh, you already did it. So you got the, you pulled out that thing and you found that the I component was 20, right?
Yeah, so then we'll just dot it.
You just dot it with,
the U.
because this is a convenient one because the axis you're interested in is the x-axis. And these are the ones that you can do it easily with,
this
with a
is the
scalar
answer.
formulation. Yeah.
Yeah.
So we just need the X.
So you just dot that with U. Yeah, so since the triple product thing is that the moment about some axis is just the unit vector of that axis dotted with the cross product.
How is he
That was just it.
Well, I thought the answer was 20.
So this is your
Yeah, well,
cross
because
product,
the
and this is your
I-
matrix to
the
do
unit
that,
vector
right?
of the x-axis is just the I.
Oh, this is the.
This doesn't look like the determinant is working right for you.
No.
I don't think that's correct.
Is there something else I have to do here?
So, the determinant
This is just the answer.
is where you take, you could do it a few different ways. There's one where you kind of do these diagonal lines.
Yeah, so that's the answer.
You can
I mean,
put
it says
the,
it wants it in
You
Cartesian
copy,
model.
I and J columns over here.
That's what they give us. So I mean, whatever.
So how do we do this? Good?
And I think these are all
Actually, no, this is right.
positive.
That is what it is in
And
Cartesian.
then these are all
There's an
negative.
I on there.
Wait, are we finding the determinant? Or
Yeah.
Are we finding
Yes.
the cross
So there we go.
product?
So
Both.
then,
It's the same thing.
Yeah. The
Yeah,
cross
there's some
product
easier way, though, if
of
you
two vectors is found by taking the determinant
differently,
of
but-
ijk and then with the r
I
vector
guess,
components and then
right,
with the,
yeah,
with
you,
the
okay,
F
yeah,
vector.
technically you're taking the determinant of IJK.
you're not taking the determinant of ijk, you're taking the determinant of this matrix. And this matrix has a row of ijk on it, a row of
Well,
the
it's
r
just
vector on it,
you're
and a row of the f
selecting the
vector.
So
on
it'll
it.
just be the same
row.
thing, but we just have to find out what the O
You're
is.
selecting
Oh,
these,
so
this
wait.
is the row of interest because we
So
see
isn't the answer just
IJ.
this?
Okay,
Well, yeah, for the
like
overall.
we're not
moment,
doing
yeah.
like this row.
But it just wants
Or this
this
column.
question. Is
So a
asking for
determinant
just the
actually
x-axis
involves the whole matrix. It's not,
And-
No,
not
I
the
know
one
that.
column.
I know that.
Okay.
But I'm
arm
saying
in just the
like when you
x-axis.
take a determinant,
just the
you
I
select
component, so-
Oh, okay. So we'd have to
One-
do some extra
one
steps.
row or one column.
But yeah,
to
this
base
is the
it
whole
off
thing.
of.
Hmm. Yeah, so you could do the other way to do it is to say, okay,
Yeah,
it's
this is the
I
whole
times this
Of
submatrix
yeah, okay,
determinant, right?
Minus
Minus j
and,
times
our
that
thing
submatrix
in
determinant
the-
plus k times
Oh,
this
the
submatrix
answer
determinant.
to
You could do it that
14
way.
Wouldn't just be.
And this is another way. Let's see if this gives you us the right answer. So these should all
I don't
be, I
think
think
so,
these should all be
because-
plus.
Oh,
And
no,
these
they
should all
could
be
just round up
minus.
to one number.
They want us to
Isn't
have
it
a
plus,
scalar,
minus,
but maybe
plus?
that scalar is.
Not
what
when you do it
that-
this way.
Do the calculator.
Oh, okay.
So is there another color marker that works? This is kind of dead. Let's try green. So what you got here then would be, you got I.
That's
So that's what I'm not seeing all these terms
Oh,
that
yeah,
you're
I
supposed
know.
to
I
be
think
including
we
on
just
these things.
Okay.
Maybe you're doing it a different
Well, I
way,
can do, like,
but
My last entry.
so
I can do
can we use
answer,
this space
but I
over here,
won't
guys?
do
You guys
that.
aren't using this room, right?
Yeah, that's fine.
So it's going to equal. So it would be I
Plug it in the computer with like
times 3 times 0, right?
Three.
Or zero,
USB
zero, zero.
and like download.
Might as well just do them all out so we don't forget anything, right?
Yeah, because mine is
Minus
like older, it's like non-super.
Oh, wait.
Plus, this is the funky way of doing it, but you can do this way if you like or not. Plus j times 0 times 400, right?
We can do.
Once you do this, you do
So that's cool, I guess.
Oh, we'll do it a couple different ways. Let's do it this way first.
3 times 0. minus
Yeah, I guess we
0
could do
times
the other
0.
one though.
Would you mind if we do it this way first? I'm kind of curious if this way works.
Except we would just dot it with the
And
different
then
axis.
it is plus k
With the unit vector of OA.
Yeah.
Okay,
times
So, I'm pretty sure.
0 times 300. Right.
Or do you want to keep it?
Well, yeah.
Okay, and then it's going to be minus
Oh, I see how you're doing.
k times 400 times 3
Here, I'll tell you. Yeah.
minus, this is going to hit I, right?
Yeah.
Minus I times 300 times, or is it minus 300?
Yeah.
I times minus 300
I realized what I did.
times 0,
Oh, eight.
and then minus j
0.3
times
I,
0 times 0.
0 K.
I
Okay.
just made a weird mistake on that.
So when you do this red marker, this goes away,
Yeah.
that goes away, that goes away, that goes away, that goes away. The only thing we have is this minus k times 1200,
Yeah, I realized.
or minus 1200k. That should be the answer. Now you do it your way
I
and
just-
see
I
if you
just
can
did
get the
it-
same
I
answer.
did it like completely wrong.
Okay. So how? What's your way? Yeah, show me your way.
looked at the two like numbered. So
Why are you subtracting? It's
Because
I times 3 times 0.
3 times 0.
Oh, okay. 0
Minus-
minus, yeah. 0
minus
minus, you're going.
300
Yep, you're doing 2 steps then. Yeah.
And
I
then-
times 0 minus 0.
Yes.
Minus j times
Right, minus j. Which is 0 minus 0.
Yep. Plus k times 0 minus 1200. Yeah.
Okay, yeah, I don't know why I did it like that because I think I was looking at these and like
Maybe 0.8
instead.
Mhm.
But this is I know
Yeah,
how to do it.
That's good. That's how you do it. Yeah, so it's minus 1200. Now, just for practice, you can do this again. Instead of having 030 there, you could have
Yeah.
400 there. And you should get the same answer.
Should, yeah.
Dot it with.
Is it going here?
Yeah. I don't know if that's gonna work. Though.
So you got a UBC.
Yeah, let's try it.
So 20. Oops.
That looks decent. And then you are, you've got your R vector, which is, what's your R again? ROB, right?
Oh, yeah, that's right.
So you got IJK,
Yeah.
142, 80 minus 40. Good. And you got I times minus 40 minus 80 times, wait a second. It's I times 4 times minus 40 minus negative 80 times 2. Right?
So if I want the I vector, cross that out. 80.
4 times minus 40 minus negative 80 times 2.
Oh, okay. Just made a little quick.
And then it's isn't it minus j times 1 times minus 40 minus 80 times 2.
Oh, I forgot that. Plus, minus, plus.
Yeah.
I get how this would work though.
And J is the minus section. Okay, it's plus.
Plus k times 1 times minus 80 minus 80 times 4. Yeah, okay, try working that out.
Okay.
You guys finished that one already?
Yeah.
14?
Because it's just like an offshoot of.
But now you have a different ROA, so you just have to do a different dot product at the very end, right?
Yeah.
Well, we didn't do the dot product for the first time. Well, yes, we
You
did.
sort of did,
Yeah,
but you didn't really need to,
we were
yeah.
just supposed to
Mm-hmm.
kind of stepped over.
Oh, done early. Did it work out the same
Yeah.
both ways? Yeah.
I don't know. I was just like doing it completely wrong
Mm-hmm.
for a second.
But the moment that we found is for F.
So kind of with like using like
Uh-huh.
vectors, instead of having like a distance, you have like the points. And by doing the cross product, you already have the distance between the points. With the-
Yeah, that all works out with the cross product. It's just,
Yeah,
yeah,
that's crazy.
yeah, it is pretty crazy.
Because the distance is like included in the position vector.
Mm-hmm. And it doesn't matter which position vector you use. That's the other kind of cool thing. ROB, ROA gives you the same answer.
Yeah.
As long as the position vector connects the point of the axis to the line of action of the force, that's all that matters. Coming out okay?
Not really.
200J minus 400K. You got minus 400K,
Yeah, I don't know.
but you got 400J somehow.
Unless I did something wrong here.
So the J terms is J times. Well, this is minus 40 and this is minus 160, so that becomes minus 200 with a minus in front. So that is 200J.
Oh,
I think you just had a transcription error there. 200J minus 400K.
What the answer is? Oh, okay.
Yeah.
Okay.
That's it.
Do you have to include the 0, I, or no?
You don't have to.
Okay. That's-
Okay, good. So we finished them all, huh?
I guess so.
Then what should we do now?
The scalar way on
We do the
this one.
scalar way for this last one?
Yeah.
And then maybe we just erase it all and have, I think Isaac and Stephanie should do the 3D ones too. You guys, did you watch the second video yet?
I didn't watch the second one.
Did you watch the second video yet?
Half of it.
Half of it, okay. Well, let's do that then. And are you guys comfortable with this stuff?
Yeah.
David and Matthew? Any questions on these before we, maybe we'll erase that to get some more room? Take a photo before it goes forever.
Yeah, so it's not student. Goes on. I know, that's what I'm saying. I'm hungry, so I can't say it.
Yeah, okay.
You got it?
So,
Yeah, I'll just look at the photo
Mm-hmm. Good.
when I have more time.
Okay, then I'm going to erase these.
all right.
eraser needs a refresher or something. Okay, so for the moment about the axis, this is the thing. And I kind of think maybe we should get Isaac and Savni to do this together, and we could kind of run them through the basic one, because I want to make sure you guys get this too.
Okay.
And so for 13, you got this pipe problem, right? You got the handout? And they kind of drew it here, and this is the thing here. This is sort of the layout. You don't have to redraw it. You can just kind of use this diagram, maybe. I don't know. What do you think? So this is the setup, right? You got this pipe, and these are the distances and everything. And they give you the force already in Cartesian form, which is good. But what they're asking for is the moment of the force, not about 0, but about the whole x-axis. Like if that was a hinge or something, and this thing was going to rotate about the x-axis, what would be the moment that would cause that rotation to take place? That's why we want to know about the x-axis.
So we need to.
And what we learn in the lecture is that in order to do that, you just take the plain old cross product of r cross f, and then you dot it with a unit vector that's going in the direction of the axis of interest. Okay.
Okay.
So, and again, the r can be any force that goes, any position vector that goes from the axis now to the line of action of the force. So you could have chosen, you guys could have chosen, I mean, you chose ROB. So actually, let's just do this. So mx is, it is the unit vector, which is really just, we'll call this ux, but we know that ux is just I, right? It's the unit vector in the direction of the axis of your axis, right? And in this problem, the axis is the x-axis. The next problem is, where's the other axis? It's the OB, or it's the OA axis, right?
Okay.
And the other problem is the OA axis. So the moment about the axis can be the unit vector in that direction dotted with the cross product of r cross f. And the r could be, it could be r OB, or it could be, like if this is a point C here, it can't be OA because OA doesn't actually connect to the line of the action of the force. But if you had a point C there that you knew, it could be RCB cross F.
Wow.
And so here is basically this position vector has to connect the axis to the line of the force.
Where's C?
I just made up C. C is right here on the x-axis.
Okay.
Okay, that's why it's another alternative. Like you're free to use OB, and you probably would normally, but you can do in certain problems. You might pick one that makes it easier for you.
So
Since we already found OB, so it's easy to-
So they found ROB, and we can just trace their work. It's not that hard, right? ROB is it's 0.3, 0.4, and minus whatever that is. What's that distance here? 0.2. Yeah, so that's ROB. And this is your F. So you're setting this up. You're doing the cross product, IJK, 0.3, blah, blah, blah. And this gives you the determinant. Now, you guys actually still did this a little bit harder than you needed to. And I'll show you, because when you do the triple product, you can do that all in one determinant. Did you know that?
Oh, yeah, you put the.
Yeah. So they did the cross product separately, and then they dotted that with the unit vector.
Yeah.
So this is the cross product. This is ROB cross F, right? Right? That's ROB cross F. And then they took and dotted that with UX, which is I, which just picks off the 20. Right? And so, great, that's the answer. But an easier way, slightly easier way, because you don't actually have to do the determinant and then the dot product, you can combine those. So you could actually do essentially UX dotted with ROB cross F. And that gives you a scalar, by the way. That equals, you just take the components of UX on the top row instead of IJK. components of ux is,
1, 0.
yeah, 1, 0, 0. It's no longer a vector. It's just a components.
Oh, right.
So 1, 0, 0, because that's ux, right? And then you got 0.3, 0.4 minus 0.2. Then you got 300 minus 200 and 150. And you take the determinant of that, and you quickly realize that you really just have one term in that determinant, right? So that equals 1 times 0.4 times 150 minus 200 times minus 0.2 minus 200 times minus 0.2. That should give you the same answer. This is, what is that, 60? 60 minus, and this is 200 times 0.2, that's 40. So that's 20. Same answer, right? Okay, that's still, I mean, that's easier, but it's still harder than it needs to be because there's a third way you can do it, which is using scalar moments. And this requires great skill of visualization. And what you do for that is, so if you want to know what the moment is, and this is, you can only do this, so the scalar method, so these are all the vector methods, right? And the scalar method works only when it is oriented along one of the axes, when the axis is one of the I, j, k's, right? So you would only try this when the axis is either I, j, or k. And the idea is you just mentally move your eye so that you're looking down the axis. And you draw what you see from that perspective. Have you guys taken Engineering 2 yet?
Right now, yeah.
Yeah, that is a great class. Have you taken Engineering 2 yet? Yeah. Graphics. Yeah. So when you look down the x-axis of this thing, you're putting your eye right here. And you're looking that way. You look at what you see, it becomes a 2D moment problem. That's all you got to do. You just got to worry about that. So when you look down the x-axis, and maybe we should just draw this right here, you're going to be seeing the z-axis coming up, and oops, I should say z, and the y-axis going to the right. And x is, you're looking down it, right? So what you see is, you see 0.4 meters over here. This is point A. You see point B down here. And what do you see of F? You only see two components of F, right? Which two components of F do you see?
J and K.
Yeah, you only see the J and K components of F. And the J component is, is the K component actually positive 150? So it's actually sort of going up in Z. It's kind of hard to tell from the drawing, right? So it's going something like, the force is going something like minus 200 in J and up 150. So it's going to be something like minus 200 J plus 150 K. I really don't like this marker. It's so fat. Who's got the blue marker? Let's try that one. That's your force, and then you know this distance is 0.4 meters, and this distance is what?
0.2?
0.2 meters, right? Yeah. Okay, that means you've got a force now that is in Cartesian form. You know the x component, or the z component is 150, and the x component is 200 going to the left. So you can now do a scalar moment about the origin, which is the x-axis, right? So the moment about the x-axis is going to equal, it's going to equal 200, and then what's the moment arm for 200?
0.4?
What's this distance right here?
Oh, 0.2.
Yeah, right, because at 200,
Oh, whoops, yeah.
And let's forget the Cartesian. It's even better to just ignore the Cartesian because you know this component is 200 and this component is 150, right? And you got to go the line of action of that force. What's the closest approach to the x, this origin here, this distance right here? Why did you say 0.4? 0.4 is this distance right here. What's this distance right here? 0.2.
Oh, I see.
Gotcha. It's this times the orthogonal distance to there, right? So 200 times 0.2, and is it positive or negative? Is it going clockwise or counterclockwise? It's going clockwise, and clockwise means negative. You got to be looking down the positive x-axis, from the positive position down the x-axis for this to work, right? If you're going the other way, yeah, then it's right. But this way, right, this is going to cause a rotation in that direction, right? And this is going to be our negative direction, so we put a minus sign there. The y component is 150 times 0.4. I should have, let's just hold that in question for a second. It's 150 times 4 because this is a force, which is 0.4 meters away. Closest approach, right? 150 times 0.4. And then which way is it causing a rotation? Counterclockwise. It wants to make things go this way, right? And we're calling this direction positive. So it's plus. So that gives us, 60 minus 40, which is 20. It gives you the same answer. And you have to be pretty comfortable with your visualization skills to be able to do that. But I like it because it shows you intrinsically, I like the fact that you can sort of link these two together in a way that makes it kind of clear what's going on. A lot of times with this stuff, we have no idea what's happening because you're just throwing it all into this determinant and turning the crank and coming up with an answer. Does it actually make sense? It's kind of hard to know when you're done, when you get an answer from this thing, if that's correct. But if it is one of these things where you just got to do it around the X, Y, or Z axis, you can get a lot more intuition about whether that makes sense or not. And it could be another check so that if you do have time on a test, you could do it both ways and make sure you get the same answer. Speaking of visualization, I just printed out something for my my intro class, which I was just thinking maybe you guys want to play around with this. This is great. Spatial visualization. Visualization is one of those things that is, let's go to a table like over here, is so important for engineers that they used to really hammer people on this. And I guess, you'll still get it sometimes, but this is one of those things where, you take so this is rotated to that, like this is rotated to that. And you stare at those things and you mentally rotate that in your head. This builds up your muscle of 3D rotation, 3D visualization. Those rotations require a lot of brain power to do. And when you do it, you kind of look at this thing, say, well, how's this thing actually rotating? Well, it looks like it's sort of flipping around this axis, right? And then it's sort of flipping around that axis. That's one way to do it, right? You could probably find a couple other ways. Can you see that?
Can you just twist it one? Oh, that's a different.
That's a different problem. So this one, right, is rotating kind of, actually, who's got a pen? You have a pen? Let's get a pen. I have a pen right here. And can you see, let's see, it looks to me like, to get from there to there, you could, a few different ways, you could rotate it first maybe around this axis. So it's going to sort of flip up. And then what's the next axis you want to rotate it around?
The Z.
Yeah, the vertical axis, right? You see that. Yep, you do it there and there. I don't know if I should have done it there, but now you can do the same thing to this guy. And which one are you going to get when you do that? So if you rotate it first around this axis.
Oh, I see.
What's the answer?
Is it this?
What do you guys think? Have me?
To x-axis? What axis?
What's
between
which of these A, B, C, D, E is the answer?
B.
What do you think, Sebby?
Yeah, B, because
And plus it says B right here.
Oh.
That's the test question. Okay, now this one, there is no answer, I don't think. So you can try this again. So this one is for that one.
D.
D.
Is it just one rotation?
Yeah.
A trick.
It's just a single
I think it's
rotation.
just one rotation. So it looks like.
Oh, yeah.
Which is D.
Yeah.
Yeah, that makes sense. Yeah. So anyway, if you want to grab those and take some home, play with them, fine. Or I'll just give them to my intro class.
back in engineering 2 class.
This is from 1976.
Oh.
Yeah, it's cool. It's from Purdue. And
Purdue Owl.
I think it would be kind of fun to, you know, I don't know what I could do about that. I was thinking it'd be fun to make a quiz out of those things.
I think I would do that.
Would be great. Yeah. Maybe an extra credit quiz for my intro class. Someday I'll do that. Not for this class, you guys. Well, we could do it for this class too. But first, I got to find someone to make it for me. Someday I'll have it as a quiz. All right. End of lecture. Thank you.